All right, so here we go. Day 2 of section 4.6, talking about arithmetic sequences. If you did not watch yesterday's video, go back and watch yesterday's video. I don't know why you guys do this stuff. All right, here we go. So yesterday we talked about the importance of common differences and what the common difference does to our line. Here we're going to put it into an equation form. So let a sub n be the nth term of an arithmetic sequence. What does that mean? So we need to talk about this sentence right here. So what does that mean? That means this subscript, this little number right here. If I want to find the third number in a sequence, this would be 3. And that means it's the third number. If I want to find the 40th number, I'm going to put a little small n here as 40, and that means it's the 40th number in the sequence. Why is that important? Well, you'll notice n is also in the formula over here. N stands for the number of the term you're looking for. If I want the 5th, n is 5. If I want the 35th, n is 35. So whatever number I'm looking for, that is n. So we put as a little subscript here. Subscripts, remember, mathematically, subscripts just mean which one. They don't do anything mathematically. Okay? So now, the first term makes sense is a sub 1. So this right here, we will always put, my smartboard's off a little bit, we will always put our first term. Okay, so n is the number of the term, whatever number term you're on. So put that in here for n. D, we talked about yesterday, that is where your common difference goes. That's your common difference. So here's our formula. The nth term, a sub n, in other words, whatever term you're looking for, is the first term plus n minus 1 times d. So what does that mean? That means this. Write an equation for the nth term of a sequence here. Gives me this sequence. So it says 14, 11, 8, 5. So what do I know by looking at this? Well, I know the first term is obviously first. So a sub 1 is 14. It's the first term. What else can I tell by looking? Well, I can tell the common difference. How much is it changing? Is it going up? Is it going down? This one here is going down 3, down 3, down 3. So D is negative 3. So the first thing you have to do is write a formula or an equation for the nth term. So that means whatever term I want to find. I don't know what term I'm looking for. Not yet. That's the second part. When you're writing the initial equation, it looks like this. A sub n equals first term plus n. Do I know what term I'm looking for? No. So we leave n minus 1 in the initial equation, and then we put d here. There you go. That's what an equation looks like. Now, part 2 of the problem says find a sub 50. Find the 50th term. So now, I have this. Do the math. It says find the 50th term, so I plug in 50. 50 minus 1 is 49. 49 times negative 3. So I have 14 plus 49 times negative 3. Calculator's going to come in real handy here today. That's going to be negative 147. Negative 147. 14 plus negative 147 is negative 133. Double check that. So that means the 50th term is negative 133. Yeah. If I'm wrong, let me know. So it gave me the sequence. I know the first number because it's the first number. I can find the common difference by looking. So then I write the initial equation with the n in it. Part 2, whatever term it's looking for, I plug into the problem and do the work. Next. Try and do these 3 on your own. Pause the video. Okay, I'm back. If you didn't pause the video, you're cheating. Well, that's on you. I told you to do it. Here we go. Find the nth term. So this formula here. So this first number is 4. I don't put a common difference in the first time. Or I don't put an n in the first time. The common difference is 1. So that should be your first equation. All right? I'm going to go through and do all these equations first. So this equation here. A sub n, first number, n minus 1, common difference is 8. And the last one, first number is 1, common difference, it's going down 1, negative 1. So those should be your equations. Now it says find the 25th term. So we plug in 25. So I have 25 minus 1 times 1 plus 4. That comes out to be, 25th number comes out to be 28. Do it again for number 2. 25 minus 1 times 8 plus 8. And 25 minus 1 times negative 1 plus 1. There you go. If you got questions, shoot me a message. We're moving on. So, online bidding for a purse. Let me zoom this in for you. I can't write when it's zoomed in, but you'll just be able to see it, copy the chart real quick so you get an idea of what's going on. Read the problem. It says online bidding for a purse increases $5 each bid after the initial $60 bid. So right now it's telling me initial $60 bid. Guess what that is? That's your start number. Increases by $5 for each bid. Guess what that is? That's my common difference, okay? I can tell by looking, 60, 65, 70, 75. It's going up by 5. Here's my initial value. So, write a function that represents this arithmetic equation. I have initial plus n minus 1 times 5. I take my initial value, the start value that it gave me, and I take my common difference, and I go and I write my equation. Graph the function. Well, I've got my chart right here. That won't be too hard to graph. I would go by 5s here, 5, 10, 15, 20, 25, 30, 35, holy cow. I'm gonna go by 10s, 10, 20, 30, 40, 50, 60, oh, 70, that'll work. So I'm at 10, 20, 30, 40, 50, 60, 65, 70, 75. Right? Not the greatest graph in the world. You've got paper, it's a little easier than graphing up here. And here, it says the winning bid is 105. How many bids were there? If you wanted to, you could plot this out till you got to 105, but that's just ridiculous. So the way that you work this out, it tells you the winning bid is 105. So we're going to take this and we're going to take my equation and set it equal to 105. Because I want to know what n is. I'm going to work backwards to find n. So work backwards. Subtract 60. Remember, a number back here, that's the distribution. I can undistribute, or I can just divide by 5 on both sides. That would be the best way to get rid of that common difference. That's going to be 9. Add 1. And I know right here that it took 10 bids to get there. Now you might be saying, well, this team doesn't count by 5, so I get to 105 and I figure out, yeah, you can, you absolutely can. Agreed, completely. But if I make the common difference, 3/4, or if I make it negative, or if I ask you for something that's maybe the 200th bid, it's a whole lot easier to use the formula. So get used to using the formula. Don't try to just count by until you get there. Use the formula, set it equal to the final amount, work backwards to find how many times it took to get there. Don't just try to count by on these. All right, so here we go. Carnival charges $2 for each game after you pay a $5 entry fee. There's the information right there. $5 entry fee, that's my first value. $2 for each, that's my common difference. Write a function, no problem. A sub n is the initial value, n minus 1, common difference. Take the information they give you, use what you know about the equation. Graph. Graph, I already told you my graphs up here aren't great. You know how to graph some points by now. How many games can you play to take $29 to the carnival? So again, work backwards. Work backwards, all right? So 29, work backwards, solve the equation. So I subtract my $5 to get in. I divide by 2, add 1. If I take $29 to the carnival, I can play 13 games. There you go. Using that formula, that equation for arithmetic sequence for day 2. We've got a review tomorrow, and the test is Thursday this week. All right, boys and girls, ask questions. You know the drill.